solving linear equations is one of the most important topics that you ever come across in algebra because we use it so much moving forward from this general idea. In this video, we're going to solely focus on very basic 1 and 2 step linear equations, but the ideas that we use will directly relate and translate to the more intricate ones that we'll see in future videos. But for now, the only operations that we will use are addition, subtraction, multiplication, and division. And I want to make one note: with multiplication, from here on out, we're not going to be using that x anymore, because x we're going to use in the actual equations. So we want to substitute, and I'll use a dot. Some people you'll see a parentheses, sometimes you'll see an asterisk. I just prefer to use a dot. It's nice, simple, very easy to use. So we have addition, subtraction, multiplication, and division. Those are the only 4 operations that we're going to be focusing on when we solve linear equations. Okay, so basically there's 2 main rules when we solve linear equations. And what linear equations are: literally equation, think of equate. It equates 2 sides to each other. Linear just means that the variables are only going to be to the first power, and that's something we'll look at in the future. We're not going to have like x to the second, x squared, so we're not going to have x cubed, nothing crazy like that. You're going to solely focus on things like this: x plus 2, that's a plus, x plus 2 equals 10. So if we have something like this, and you've seen these before, in elementary school when we first saw these, except it looked like this. It was, maybe a underline plus 2 equals 10, and you had to guess what this was, and you would go through your process and say, oh, is it 1? Is it 2? All the way up, and you would find out, okay, it's 8. Now we're going to take a sophisticated approach to actually solving these, because we were not going to be able to do that in the future when we have parentheses and all these coefficients everywhere. We're not going to be able to guess. Okay, so there's 2 main rules that we need to remember. Anything we do to one side of the equation, we have to do it to the other side. That's what this equal sign means. It doesn't matter what these variables represent, and this x could be a, b, it could be anything. It doesn't matter what it represents, but the values have to be the same. X plus 2 must equal 10. So anything we do to one side, let's say I added a 2 over here, another 2. If I just do that, I completely change my equation. But if I do it to both sides, I don't change it. It remains in balance, okay? And to do this, the main idea behind solving linear equations is we want to solve for this variable. In this case, it's an x, and actually about maybe 90% of the time it's going to be x when you first start out. When you want to solve for that, you want to isolate that. So anything that's not that x, we want to bring it to the other side. In this case, there's a plus 2. So what we do is we do the opposite operation. It's technically called the inverse operation, but I like to use the opposite. It sounds a little bit easier. So when you think of opposite, the opposite of addition is subtraction, and vice versa. So the opposite of subtraction is addition, and then multiplication, and I just did it right there. Multiplication with the dot. The opposite of multiplication is division, and vice versa. The opposite of division is multiplication. So with this, you notice we want to get that x by itself, and there's a plus 2, so we do the opposite. The opposite of addition is subtraction, so we subtract 2, but we don't just do it to the left side, we do it to the right side. And we'll bring down this x. That x remains unchanged. 2 minus 2, we just get 0. So x plus 0 equals 8. Anything plus 0 is just the anything, so that remains unchanged. So we get x equals 8. And what I love about linear equations is you can take that value, plug it back into the original equation, and see if it works. Is 8 plus 2 equal 10? That is true. So x equals 8. And we can apply that to any number of different equations. If I gave you x divided by 5 equals 10, what do we have? We have division by 5. Okay, well, let's see. We want to get x by itself. We don't want that divided by 5 on it. So we have divided by 5. What's the opposite of division? Hey, multiplication. So let's do that. Let's multiply it by 5. And then the other side, we have to do it as well. So the 5's cancel out to 5 over 5. And you might think, okay, well, 5 over 5, that's just a 1. So do I get a 1x? Or an x? And those are exactly the same thing. We just don't like to write 1x. We just like to write x. It makes it a lot easier. And then 10 times 5 is 50. And again, let's go back and double check. X divided by 5 equals 10. That was our original. So is 50 divided by 5 10? And once you check that out, that is true. So in this case, x equals 50. So with these, when we take it a step further, what we're really doing is, if you remember the order of operations, we're kind of going backwards when we solve. So if I gave you something like, let's see, let's switch up the color. Let's say I give you 2x minus 7 equals 56. Okay, so what we want to do is we want to get this, the 2x by itself. So normally, if you think of order of operations, we do the multiplication first before the subtraction, but now we're doing it backwards. We're kind of undoing what we used to do. So we're doing the opposite of subtraction, which is addition. So we add 7 to both sides. Have to do it to both sides. Those just cancel out. 56 plus 7, what do we get? We get a 63, and we still bring down the 2x. So we get 2x minus 0 equals 63. Again, that 0 doesn't do anything, so we can just rewrite that as 2x equals 63. Now what do we have? We have 2 times x. We want to get rid of that 2, so the opposite of multiplication is division. So we divide, and we can just leave it as x equals 63 over 2. Now let's go back and double check. Let's plug it back into the original equation. 2 times x, which we just found is 63 over 2. What do we get? Minus 7 equals 56. Is this true? Well, when we multiply these two fractions, if you remember fraction multiplication, we just multiply across. But what I want you to see is we can actually cancel out these two 2's because it's 2 divided by 2 to get a 63 minus 7 equals 56. And when you do this, you confirm this becomes a 56, and 56 is indeed equal to 56, right? So this original value that we got is correct. Okay, so that's a two-step equation. So the first step, I forgot to say in the very beginning, the first two that we looked at were one step. We just had to add something or multiply by something. In this case, here's step 1, and then step 2 was down here. Okay, and you can see technically this is a multi-step equation, but multi-step ones, they'll be like 2, and then we'll have a parentheses, x minus 2 equals 10, something like that. And maybe actually there would be like a plus 3 out front. Okay, and we'll do that in the next video, but I want you to get a good intuition behind what the process is of how we solve linear equations. First off, what a linear equation is. The most important part, besides the 2 rules that I told you up here, which again, you have to remember these. These are cardinal rules. You cannot not do those because you'll get a completely different answer, which will end up being wrong. But the other, I guess I should have put a third up here, is this right here. Equation. When you think of equation, you think of something is equal to something else. It doesn't matter what the 2 sides are. We don't know what x is. X could be the number of apples that I bought one day or something, anything you could think of. It doesn't matter what the variable is, it represents, as long as we know that the 2 sides are equal. So we're looking for the value of that variable that sets these 2 sides equal to each other. Okay, that's the big idea. And then these 2, of course, are very, very important. Anything we do to one side of the equation, we have to do it to the other. And then to get rid of a value, we just do the opposite operation still on both sides of the equation. So if it's plus, we subtract. If it's dividing, we multiply. If it's multiplication, we divide. And if it's a subtraction, we add. Okay, so this is just a general primer. Again, we're going to go deeper with these, but I want you to get a good idea of what exactly we do to solve a linear equation and kind of think of a reverse order of operations when we solve it. So we're going to do our addition subtraction first, and then I call those loose change ones. If you look at number 1, this minus 7, we want to get rid of that first. So we added the 7, and then we have this 2x equal to something else. So if you have any questions or comments, please leave them below. And until next time, this is Justin with Top Tier Math.